This episode is brought to you by Camilla Najat with Exit Realty Metro.
Camilla Najat is an experienced real estate agent who prides herself in finding the perfect home for her clients. Camilla can help you with a comparative market analysis to help determine the value of your home if you're planning on selling, or help you determine the going rate for the neighborhood you're moving into. She can also work with you at your pace.
You can reach Camilla by calling 902-880-8429 or email camilla@exitmetro.ca.
Also, you can find her on Facebook at Camilla Najat, Exit Realty Metro.
Cheers!
Cheers.
And welcome to the Afternoon Pint. I'm Mike Tobin.
I am Matt Conrad.
And who's with us today?
I am John Reed.
John Reed.
All right, what does John do?
What do I do?
Well, apparently you're an astronaut or something
Astrologist? Horoscopes?
Oh, man. I think that would actually be a fun job.
Okay.
Just making up futures.
Yeah, it'd be cool as heck. Why
like
not?
that. It would be.
Putting it in the paper.
Yeah,
Yeah.
that would be good. Put it in the paper. That would actually be a fun job. But I actually think that what you actually do and what you studied, because you said something interesting earlier that, what are you is like, is it your job or is it what you studied? But I think what you do and what you studied is very interesting. So why don't you tell everybody what that is?
Sure,
Yeah.
And and just before you start, I should just glitch really quick. We're at the Halifax Club again today.
Yeah, this is
yes. And in honor of our guest,
That's right.
we are drinking Propeller Galaxy.
So good.
Now that we're introducing the guest, we'll know exactly why we selected the Propeller Galaxy for tonight's show.
Exactly. All right.
Well, first, thanks, Matt and Mike, for having me on the show. This is wonderful. It's great to be here. Thanks for the beer.
Yeah, our pleasure.
But yeah, so what do I do? I think overarchingly, I am what you would call a science communicator.
Awesome.
Okay.
And I didn't intend necessarily to get into this profession per se. I was in corporate finance beforehand. I would do forward-looking accounting statements and help CEOs talk to Wall Street. Like, that is old John.
That seems
which
lot
was
more boring.
a little bit, yeah. Like, I mean, it's interesting, but it wasn't for me.
Fair enough. Yeah.
Yeah. People love They love them some Wall Street. Some people.
Well, I mean, people love money, so that
they
makes
like
sense.
money.
Money's
Yeah.
interesting. That's true. But yes.
Yeah, so I fell into this helping kids learn how to use telescopes. That's how I sort of fell into it. But if you even back up a little bit more, I was 27 years old. I went to a CVS pharmacy and they had a telescope that was really terrible, but I didn't know that. It was like $13.99. And I bought it and I took it home. And a few months after having it, I took it out and I pointed at this bright yellow star in the sky. And to step back a bit, we're in like San Francisco. There's a subway going by like above ground. It's called BART, Bay Area Rapid Transit. Like, there's lights everywhere. The absolute worst conditions for stargazing. So I go out in front of my apartment building. My wife and I had just got married. I put this telescope up and I pointed at this like yellowish looking star. And when I looked in and focused the telescope, you got to turn those focusing knobs, it was Saturn.
Oh,
and I saw the rings, and I saw this little moon Titan that is found by
With a
Saturn.
$13 telescope.
With a $13 telescope.
Cool.
And I was like, wow, if I can see this
yeah.
with a $13 telescope. Now, I don't recommend you going out and buying a telescope this cheap. Saturn just happens to be fairly easy to target at some points of the year. But it did it for me. And then I went out and got a bigger telescope. And then for Christmas, my wife got me a really big telescope. And then I have to share this. So I started working with kids. I joined the local astronomy club. They had an outreach team that would go to the schools and teach kids about astronomy. And so I joined that club. It's called Mount Diablo Astronomical Society in California. But I found that I needed a list of objects for me to reference every night. And since the sky turns over about every 3 months, you get a whole different sky in the evening. I was like, all right, well, I'll pick the top 10 targets from every season. And then add the planets and the moon. And if it's early and you have a really good solar filter, you can look at the sun with a telescope. Again, with a commercial solar filter. Don't just go looking at the sun with a telescope. And anyway, I put it in a book, made it into a PDF, and I put it on Amazon. And after about a year, it started selling
What year was this?
Crazy. This would have been 2013.
Okay, cool.
Yeah.
And this is one of the books here?
This is the first edition of the first self-published 50 things to see with a
Small
telescope.
Telescope. That is so
That
cool.
is very
With a small
cool,
telescope.
So I mean, I got to let you know, like, so just this last summer, Gracie started to inquire about this. I got her very first telescope. And, as a parent, sometimes you're like, this could be like the next big thing, or this could be the one time I look at a telescope thing. And so I've learned over the years to invest lightly first. And if it's something that they're really interested in, you kind of, then you can kind of look at a bigger and broader telescope. So similar thing, we got a $20 telescope and set it up in the backyard. I mean, really, we only were able to see the moon with it,
Yeah.
but it was remarkable, right?
Yeah. No,
And
the
she'd
moon
be
is
taking that out every night of the summer, right? And in the fall and into the winter. And now where she's looking for an upgrade.
I bet. Yeah. I mean, even if you've got a good telescope as your first telescope,
Yeah.
you should really practice on the moon, because so many people get telescopes. They don't know how to focus them. They don't know how to point them. And the moon is a great way to start. It's bright. It's big. It's in the sky in the evening about half the month. And it's a good way to start. Now, that said, I don't necessarily recommend you go out and buy your kid a $20 telescope, because there's also, you want them to win and succeed.
Yeah.
And with a telescope that is under, it doesn't meet this set of minimum requirements. And I talk about this a lot on YouTube. It can be a downing instead of a downer. Instead of having wins, you have losses.
Right.
And so I have a list of, like, when I'm recommending a telescope for kids or for a beginner, I have a list of 5 things that I keep in mind. And you can actually whittle it down to 3. One is aperture. So the most important thing about a telescope is that it's fat. Like that mirror should
Really?
be big.
Okay. Yeah.
Yeah.
So those big stubby
The big
ones.
most of the long ones, if they're targeted at little kids, that's just for show. And it also allows them to use lower quality optics and still get decent results. That's why they stretch them out, give them a long focal length.
But only to a certain point.
Yeah. But the quality of the image is determined by the aperture. So how fat the lens is, how fat the mirror is, its diameter.
Okay. So back to San Francisco. What kind of telescope did you have?
Oh, the
$19
worst.
telescope.
Yeah.
Long,
it was
skinny.
long and skinny.
Okay.
Yeah. Like 50 or 40 millimeter aperture. So I recommend 100 millimeters.
And how did you manage to see Saturn with that? Because that's what my disappointment was, of course, with the cheap telescope. We didn't really see very far beyond the moon with this thing. We
You probably could, though, in the right.
Maybe we could.
in the right sky.
Yeah, you could.
Yeah. Any telescope should be able to see Saturn. And I think the test is it easy? Is it, assuming you know where Saturn is, because it looks like a big yellow star. And then depending on how close Earth is to Saturn, that determines how bright it's going to be.
Right.
And, if it's difficult to get Saturn in the telescope, then maybe it's not a very good telescope. If it's easy, then maybe your telescope's pretty good. Yeah. So that's the one thing, is like the diameter of that mirror, because that's going to determine the resolution. It's like having, an iPhone 3 versus an iPhone 14.
Right.
Your resolution in that 3 from 1998 is going to be not so great.
I mean, you're starting people on telescopes. You start them on this, like, I noticed a lot of it's digital now, where you can put the coordinates in and such. Like, are you starting them with that kind of system, or?
It depends what you're into. If you're into coordinates, you're probably leaning towards photography.
Right.
But if you're just like, hey, let's experience the night sky for what it is, no electronics, just like Isaac Newton or Galileo did when they used their telescopes. And telescopes for visual observation, not, no electronics, no cameras, that hasn't really changed since the days of, Isaac Newton and even Galileo, if you're using a refractor that's lens-based telescopes.
Yeah, just lens and mirrors, essentially.
In Galileo's case, just a couple lenses.
Yeah.
But the second thing is that you got to find things in space. If they're up there, you got to find them. So you have telescopes typically have a finder. You have your main telescope, and then some of them have this little finder scope. If that finder scope is small, it's not going to do you any good. And also, when you look into it, a lot of the time it's what's called mirror reversed, and so you'll push the telescope one way, and the image goes the other.
Right.
And you get all confused, and sometimes it's upside down, and you're like, oh, my head. And you give that to a kid, and they're like, not for me. This is too hard.
No, go left to go right.
Yeah,
I was coaching Gracie on that exact thing. Wow. So this is a big mother one you have here.
Yeah, you have
This
is not like
prop here.
It's a very fat, but kind of.
It looks like
so-
a gigantic tomato soup can with some fancy things stuck
He
on
brought his
either side.
thermos.
of
It does look like a thermos. It's about as so. I'm holding a small telescope. It's a Smith Cassegrain. It's 5 inches of aperture, so you can see there's a mirror in there.
Okay.
The mirror is 5 inches, so we're about 1 inch larger than I would recommend here.
Okay.
But what I'm explaining here about the finder is we've instead of a finder telescope, all we have here is it's called a red dot finder,
Right.
and
It's a little battery
Oh, it's
powered.
like, it's like a sight on
You've got
a.
a little 2032 battery. It's probably similar. I wouldn't know. Similar to a gun sight.
That's what I was gonna say. It's similar to a sight on a.
Yeah. You look in, you see a dot. You put that dot on what's cool in the sky. Let's say you're looking at Saturn. There you go.
So why do you find why is it that Saturn's so easy? Their size, but I mean Jupiter's also quite large. It's larger, in fact.
So Jupiter right now would be what you would point at.
Look at, okay.
After you've exhausted your time with the moon.
Because I also read something kind of more recently that I think the way that you learned about the solar system, I knew this kind of as an adult, but not. But the way I think people visualize the solar system is like everything's all in a row, and it's like start off with Mercury, Venus, Earth, Mars, whatever, right?
Yeah.
But I read recently. am aware that sometimes Jupiter's on the other side of the sun and all that other stuff, right? But what I read recently is that Mercury is like predominantly the closest planet to Earth most of the time.
Yeah.
And it's also the closest to Venus and Mars.
It's the closest to every other planet. And that's really, it's a simple reason why is that for half the time, all the other planets are on the other side of the sun.
Right, exactly.
And Mercury's near the sun, therefore it's closer.
Yeah.
Yeah. That's pretty cool. A really cool fact. But now Mercury is one of the hardest planets to see with a telescope.
Because it's so close to the sun?
It's close to the sun. So it only is above your horizon at night when it's dark enough to see it for a few days a year.
Okay.
And so you'll get it for a few days in the evening sky one time of the year, and then later in the year, a few days in the morning sky. Jupiter and Saturn and Venus are the easiest.
Yeah. New Venus we'd see a lot. And you can see Mars. Mars pops up sometimes around near the moon or something like that, I believe.
So the moon passes by all the planets every month.
Well, of course, it's in front of us. Yeah.
So sometimes you'll see Mars near the moon. Mars gets fairly bright. Yeah, about once every 2 years, it gets really bright when they're close. Yeah. But
I think it's every time I think I've seen Mars, I think it's always been like just off of the moon kind of thing. So I always that's why the way I envision it in my head for some reason. I don't know why.
A lot of people are like, "Oh, that bright star near the moon, that must be Jupiter." It's just like I think people see the moon, they look up and they're like, "Oh, there's a star beside it."
Yeah.
And then you associate the two. But, the moon is going around the Earth about once a month, so it's going to go. And almost everything in the solar system, like you're talking about, it's not in a straight line, but it is in a plane.
Yeah.
So the plane is called the ecliptic. And so it's a part of the sky that's where all the planets are. And they're all going to be somewhere near that ecliptic, sometimes a little above, sometimes a little below. Their orbits are what's called inclined versus the ecliptic. But they're all somewhere near there, and the sun. This is the path the sun takes across the sky.
What about Pluto? Rough deal, or like what do you?
Yeah, no, it's interesting. I think
did Pluto get the short end of the stick?
I really think we should grandfather Pluto in. What do you guys think?
Sure.
Yeah,
Why not?
But I guess I'd be okay with it. It's just I do know that that they've discovered that there's like 2 or 3 other dwarf planets that are out there.
Because I think it started with a world called Eris.
Yeah.
Eris. And so there's this discovery, another body like Pluto out in the Kuiper Belt, which is this rocks and stuff are where Pluto is. And so they had to come up with these rules. Otherwise, you just have too many planets. And then that determines who gets funding, and because you want missions to go see these things. And what was kind of cool though is that, and I forget if it was who it was that sort of got the funding for the Pluto mission, but the Pluto mission, New Horizons, got funded right before Pluto got demoted, and so they just snuck a mission in there because the missions cost like hundreds of millions of dollars.
Too late, guys. The ship's gone.
I know. So it's a Discovery class mission, which means around a budget of between $200 and $400 million. Spacecraft was designed and built at Johns Hopkins, where I'm currently a master's student.
Oh, cool.
And so it launched in early 2000s, and it got there in 2015. Took 9 years. just a really cool mission. And what was really neat about the Pluto mission is we didn't know what Pluto looked like at all before we got there, right? Because you don't have the resolution. You need to be there.
Yeah.
And so the spacecraft gets closer, and within about 6 months of flying by, it had too much energy to stop, so it was going to fly by. But after about at 6 months before it's going to hit, we start getting data, and then we start getting closer to Pluto, and we realize that there's a landform around Pluto or on Pluto's surface that's shaped like a heart.
Oh yes, I saw this.
Yeah, and so then everyone fell in love with Pluto all over again because it's got this beautiful heart. And then one of the reasons why Pluto's not a planet, and it falls into the hasn't cleared out its orbit category, is that it shares a center of mass with its largest moon, Charon.
Yes.
I don't know if I'm pronouncing that right, but so you got Pluto, and right by you got Charon, and they're tidally locked, so they always face each other.
Sounds like a Pixar movie waiting to happen.
It does.
Pluto and Charon.
Yeah, so you got Pluto and Charon, and they always face each other. And Charon, it's a moon, but it doesn't go around Pluto in the traditional sense. It's too heavy compared to Pluto. They orbit a barycenter, which just means a center of mass that's outside of Pluto. So it's sort of hanging out there in space, and so they both sort of orbit each other around this point in space.
Interesting. So kind of like this, almost like do you mean like the infinity kind of swirl? Almost?
Yeah, it's some sort of weird, like,
oh, cool.
Yeah. And of course it's got 4 other moons. I don't remember their names, all like Nyx and Styx and underworld names. I don't know.
Yeah. That's it. Yeah. So I mean, I would be okay with, I guess, kind of grandfathering it in, I guess. But
sure.
Yeah.
We kind of get downgraded. But how long does it take to send data from Pluto back to Earth? How long does it take to get the data back here?
I think it's about 5 hours each way.
It's not too bad.
That's actually
that's a rough estimate. Yeah.
Considering it takes, like you said, was it 6 months or something like that for it to get out there, or how long was it
that was really fast. That was like one of the fastest to Earth. When you leave Earth, that's when you use your rockets and you coast the rest of the way.
Yes.
Mm-hmm. Yeah. And so it was it left at like 70,000 kilometers per hour or something really fast. And then it picked up, you lose speed as you get away from the sun. You lose energy. And then it picked up more energy at Jupiter. So you can borrow energy from the planets using the correct trajectory. It's called a gravity assist. Yeah. And so, Jupiter is going to get 0.000% slower, and then the spacecraft gets just a little bit faster.
Wasn't there something? What was that? Was it like a Star Trek or something where like they used the planet to like zoom around? And
that was Star Trek 4. Yeah,
I knew
that's when they say to go save the whales.
I'm not a big like Trekkie. I watched a little bit here and there. I'm more of a Star Wars guy, but
Star Wars for me, and then the new one. What was the one with Seth MacFarlane did? Man, that was fun.
That'd be Orville.
Yeah. Have you watched that?
I'm not up to date on the Orville.
Yeah. That was pretty good. It was very enjoyable.
That's on my list.
It's like a slow start, and then after like 2 episodes, it just gets extremely smart and fun, and rips off Star Trek quite a bit. But great show,
brilliant.
Yeah,
I do like Lower Decks, and I'm not caught up in that either.
Oh yeah,
but they did in the most recent live action, one, right? The animated one. Mm-hmm. Yeah, they did a crossover, which I think was some of the most brilliant television, where the animated characters, or 2 of them, they fall through a portal and become live action.
Oh, geez, cool.
And then they're also falling back in time, and so they meet the crew with like Kirk and Pike and Spock. And
these shows have the ability to renew themselves forever, like Star Trek, especially. I think they could just kind of always they could just be made till the end of time.
Well, because
we're always going to be curious about
is
space.
Constantly wondering about it, right?
Yeah.
So it's like it's this whole thing of like people who are into it. I mean, obviously, there's people who aren't into it, but the people who are really into it and wondering about what's beyond us and the greater things and all that stuff and big bangs and everything, multiverses, whatever you want to get into. People are just wondering. Like, and I think that it's literally
that makes me want to ask a funny thing. Like, so kids today and all the multiverse stuff that's going on in Marvel and the cinema movies, are they asking you about multiple universes? Are you getting that question a lot?
Got that question?
No,
okay.
Really?
I thought you would.
But we talked about this before the show, that you sort of get into philosophy when you get there, because we don't know if there's other universes, but it's a cool thing to think about. And I think you can do it mathematically, not my department. But yeah, like it gets into philosophy of like why we exist, how we exist. Like if there's an infinite number of infinite universes, we have to exist, which is cool from a philosophical standpoint. But we don't know if the universe is infinite, and we don't know if there's infinite universes. So,
Well, that's the thing. I mean, we can see that we're expanding. So we can see, because we can actually look back in time through satellites, looking at the the static radioactive.
So there's the microwave background radiation.
Yeah.
And so that's all been mapped, and
that's been mapped. So that's essentially what they're looking at, is like they're saying like that's the start of what the universe looked like.
So that's in microwave light. Yeah.
Microwave light.
And so, but even using regular light-based telescopes, you can look at the galaxies there, and you can see that they're receding. And every galaxy is basically, unless they're gravitationally bound, getting further away from every other galaxy. So new space is sort of showing up in the spaces between the galaxies. It's probably an overly simplistic way of saying that.
I just thought it was interesting when there was we were talking earlier how much I like Neil deGrasse Tyson. I listen to everything this guy says. So it's like, I like one thing that he was talking about how if there was essentially a big bang and it's, cone shaped, kind of sending things out, then it's quite plausible that, there's other cones that are coming off of that, or potentially inverted cones, like basically like kind of time going the other way, or like inverted that way and everything. Cool. It's all it's science, but it's, as you said, it's philosophical science, right?
It's philosophy. It's philosophy, yeah. Because until you have data, it's philosophy. But it's really fun to talk about.
It's really fun, and people have made like their whole careers and get lots and lots of money and grants to come up with these theories and solutions and whatever equations or whatever. Yeah. So it's pretty cool. I mean, it sounds science fiction-y, but there's people who have, like.
So you mentioned earlier about these books. Sorry to go back to these. I just had another question. You talked about YouTube a bit. So do you have like an active YouTube channel that you promote, or?
Yeah, so I'm Learn to Stargaze on YouTube. And it's kind of funny because some people call me Learn to Stargaze as a name. Yeah. And then they call my wife, because she appears on the show sometimes. They call her Mrs. Stargaze. Oh. Yeah, so we're fairly small.
That's a cool family name.
We get a couple 100,000 visitors a month.
Yeah, that's great.
And then more at Christmas.
Yeah.
And we are, we're monetized. We get sponsored. The videos are sponsored. Like All Star Telescope sponsors us. And then we
That's awesome.
It was funny because like at Christmas last year, we had a house sitter because we have the dog. And when we got home, the living room was like floor to ceiling telescopes that companies had sent us. And I knew they were coming, but I didn't realize how big the boxes were going to be.
Holy
I felt
smokes.
so bad.
So do you do telescope reviews? Is that a spin-off, or have you thought about it? Or
I do a lot of telescope reviews. I don't really think of them as reviews, because fundamentally what I wanted to do is teach people who have telescopes and don't know how to use them. And a lot of the reviews are of telescopes that we wouldn't recommend because people have them. And I'm like, well, you got to work with what you got. So I've got a whole bunch of videos that they're demonstrations of how to use these, how to make the best of these telescopes. And usually at the beginning, I'll be like, if you're thinking of giving this to someone, like, you might want to reconsider these other telescopes. But if you've got this telescope, it can be a lot of fun. Here's how to make the best of it.
Well, that's good.
And
but then the telescopes take a crazy jump in price, right? You can start.
So there's telescopes at every price, but there's good telescopes at every price range. There's a lot of bad telescopes at every price range.
Yeah.
And so that's good. And there's far more bad telescopes out there that are just sort of marketing gimmicks than there are good telescopes.
And I mean, not to say anything, but like Costco had one on, right? And so I was going to get it, thinking about for Gracie for a Christmas present. We actually didn't get it because I looked at a bunch of reviews. I checked what a bunch of people had to say about this particular telescope. I won't say which one it was, but it was trashed. It's interesting. It wasn't like trashed by one. It was trashed by everyone, almost unanimously.
Yeah.
I'm like, okay, this must be no good.
What's interesting about telescope reviews, though, is if you look at some of the most popular telescopes, like let's say on Amazon, they've got the Power Seeker series by Celestron, the 127 EQ. 4.5 stars on Amazon. Right. People saying, "Oh, I got it. The shipping was good." Whatever. Yeah. That is one of the most hated telescopes in the astronomy community.
Really?
Like people bring it. They're like they'll bring it to. We have these telescope clinics once in a while, And you can come in and get help with your telescope.
Oh, cool.
And they come in and like even the astronomers can't get it working. Like they're just so frustrating to use. But they've got great reviews.
I'm
And
pretty
there's-
sure that's the one in the living room. not positive.
it's fairly popular.
Hey, it's good to learn on something that's difficult, though, I think, in a sense. I know what you were saying earlier, but I also think, sometimes when you really have to answer the call of the challenge, it makes people rise to
We
the
call them the
occasion a bit.
hobby killers. So there's a lot of telescopes out there that aren't that much fun.
Hobby killers.
And I think if I had it, so my dad had this Bushnell telescope on this yoke. It's called a rod and yoke mount. So it's got this bar that sort of runs down the side. And I could not get it working as a kid. And my dad was no help. He wasn't interested in astronomy at all, but he had this telescope. He just said, hey, and I'd point it at Jupiter and I wouldn't be able to get it in focus and it would be frustrating. I even tried to take photos with it with a 1998, whatever we had as a camera back then. Gosh, they weren't even digital. Anyway, but I always think back, like I didn't start my astrophysics degree until I was in my early 30s. If I had known that astronomy existed as a field that was interesting back when I had that telescope, and if I had have had success with it, I might have had a very, very different career.
Yeah.
Right.
You know, I might have, instead of getting a business degree, I might have actually gotten
Fantastic
an
that
astronomy degree.
you pivoted though,
first,
right?
yeah.
And tried and chased your passion. Doesn't matter the age, right? You're there now.
Yeah, I mean, we were really lucky that we had this business that just materialized around these books. It wasn't necessarily intentional. Like we knew the books were popular, and I was still working as in corporate finance in California at the time. And I'm Canadian. I just got a job in California right after I graduated. Cool. Pretty lucky there. Anyway, so this business sort of formed up around this book. We translated it into 10 languages. We reformatted it to make it look more pleasing. The sales went up. I was able to quit my job. We moved back to Canada where I could afford to go back to school. Tuition's a little bit cheaper in Canada than it is in the States. Didn't know that. We moved the family at the time. I had the dog and the 2 cats and the wife and the 2 kids. And we all drove up here to Canada and then it almost exploded from there. In terms of we started another book, 50 Things to See with a Telescope for Kids, and then that one was self-published. Then we went to a publisher, and we was like, well, we really don't know what we're doing, and so they're like, all right, well, we'll buy your next book, and then we ended up doing 5 books with Formac Publishing on Atlantic Street in Halifax, which was wonderful to get me into the world of professionally publishing and professionally marketing books.
I think, in fairness, like you say for kids, but looking at this book. I mean, if you wanted to ever figure this kind of stuff out and get it quick, it's a fantastic way to learn just to kind of flip through this book.
And it is true. Like I write these books for kids, but I think deep down, or I know deep down, I'm writing them for adults.
Yeah.
Because fundamentally, if you've got a kid who's got a telescope, really the adult needs to learn it and teach it to the kid. I have a son that turns 10 next week, and even with him, like I still have to sort of hold his hand with the telescope. He's not ready to take that step and go enjoy a night under the night sky by himself.
Yeah, and these are the things we were actually trying to figure out in our own backyard. What's Gemini and what's Orion and all
the constellations,
all the constellations, right? Because it's some people know, and some people we're just kind of take it as it goes.
Yeah. Also, you can only find some of them at a certain time of the year. Right, too. So
So that's why all the books are divided by season. And then they show the evening sky in that season. So around 8 to 10 p.m. Because obviously in the summer the sun sets a lot later, and then in winter it sets really early, but no one wants to go outside.
Yeah, that's a good point too. But yeah, this is
really cool books.
These are cool. My son is only he's only 2.5, but honestly, he loves space. His favorite pajamas are the ones with the rocket ships on them and things like that. So he's
So there'll be stuff for him coming out soon. Oh, cool. A lot of it is confidential. So I now use Source Books as a publisher, and so I have an agent in Manhattan, and then Source Books is a division of Penguin Random House.
Oh, okay.
And so major publisher, and they do a lot of board books, and so I have a contract in the works to do board books for almost a 3-year-old age group. But again, you're writing it knowing that the parents are the ones going to be doing the actual learning.
Of course.
Yeah. So this YouTube channel, are you seeing kids now kind of getting into your same field because of, maybe a little bit of what you've done?
So I can tell from the comments, and that's really the only way we can interact with the viewers,
Right.
that I'm inspiring a lot of people. And so I spend probably an hour a day responding to YouTube comments.
Oh, cool. Yeah.
It drives my wife crazy. What are you doing on your phone? I'm working. But yeah, and most of them are positive.
Yep.
I try not to be too controversial. I know earlier we talked about that Power Seeker, a 127 EQ, and I have a video where I was like, yeah, beginners could probably not start with an EQ telescope. That means it's equatorially mounted. Its movement is limited because they want to lock you into moving toward and away from the North Pole and around the North Pole. So you're locked to those two movements.
Okay.
You can't just push the telescope. And so for me, I find that very frustrating. I just want to push the telescope over to Saturn. But an EQ prevents you from doing that easily. You got to sort of go one way and then go the other. Anyway, so I posted this video and I'm like, beginners, EQ mounts, not so much. And so then I got like a week's worth of hate mail from all the people who had started with EQ mounts. They're like, I love my EQ mount. You don't know what you're talking about. I'm like, well,
wow, you upset the
idea.
But the telescope.
But if I step back, So here's the thing though, like between
what you should do? I'm just
a fragile community. Just joking.
No, but I'm just sitting here thinking like, you get the telescope people upset. It's like you should the guy who rates the pizzas.
Yeah.
You should just go and grab telescopes and just rate them from 1 to 10, and just like if it's below 5, just throw it on the ground.
Throw it on the ground.
Well, I had one video where I did the punch test. I did this video as a gag because you had this telescope from Canadian Tire, and it showed like the Orion Nebula, which is a bright, colorful nebula in the box, but it's not bright and colorful when you look in your telescope just through your eyes.
Yeah.
And so I came up with these 5 tests, and one of them was like, oh, there's a 6th test. It's the punch test.
Right.
Because the telescope should be able to take a punch without really moving too much. And so this telescope was made of plastic, whatever, and I punched it. And then I blurred it and gave the colored bar TV. So you didn't actually see me punching the telescope. But I went around like punching I set up like 5 or 6 telescopes around the lawn and was punching them all to see if they'd move.
I think a punch test is pretty appropriate for young households.
I think the punch test should be used for lots of different things.
Yeah.
All right, so everyone would. I think people would be definitely expecting that we bring up something that we talked about in the beginning, and that's life on other planets.
Ooh.
Yeah, we got to ask, man.
We got to talk about
the Fermi
it.
paradox.
The Fermi paradox. That's what I wanted to ask about. Yeah. So what are your thoughts on the third?
What's the Fermi paradox for people that don't know?
Okay, so it's been a while since I thought about it, but just stepping back, life on other planets.
Right.
Okay.
So as astronomers, for a lot of astronomers, it's literally their job. This is probably like thousands of people around the world. It's their job to look for life on other planets.
Exactly.
Yeah.
Actually, it's probably in the tens of thousands because, we're looking for life on Mars. We're looking for life on Enceladus, which is a moon of Saturn. We're looking for life on Europa, which is an icy moon of Jupiter that has a liquid ocean. We now know that several of the other moons around Jupiter have liquid water oceans just because the middle is hot and the top is ice. So there's going to be some point in between where it's liquid water. We can't get to it because maybe the ice is 100 kilometers thick, but that's the perfect place for life to form because it's stable for billions of years.
Right.
So then you've got the Fermi paradox. And so basically what it is you take the probability of, or the Fermi paradox figured out the probability that there's going to be an intelligent species somewhere out there in the universe, not just our galaxy. And so it basically multiplies all these probabilities together. So one of them might be like the number of planets or the number of stars, the number of planets in the habitable zone.
Right.
Because there's around every star, there's a Goldilocks zone where it's not too hot and it's not too cold. But I think the Fermi paradox is fairly limited because you have that Goldilocks zone, but there's so many other ways where life could develop. You have we're talking about these moons of Jupiter, right?
Yeah.
They're hot because of friction, because they're moving closer and further away from Jupiter. They're stretching and compressing. And so you get this friction that, when we get our heat from the sun, They get their heat from kinetic energy.
Right.
And so that totally expands the number of places in the universe where life could be. And so, but if we just look at our galaxy, so our galaxy has, I don't know how some grad student counted it, but there's 300 billion stars. That's just the way it is.
Yeah.
There's 300 billion stars. And around every star, there's probably a solar system. Could be similar to ours, could be different.
Right.
But there's way more planets than there are stars.
Right.
Maybe there's 3 planets for every star. It's probably a lot more. But let's say it's 3 something. Then that means there's 1 trillion planets
Yeah.
in our galaxy. And that's just our galaxy.
Right.
And there's trillions of galaxies. And again, we don't know how big the universe is because we can only see so far. Because as you were saying, the further you see, you're seeing back in time. So there's a limit to how far we can see. But let's pretend for a second that we weren't limited by that constraint. As far as we know, there's galaxies forever.
And just to kind of as a sidestep to that, like, do you think that like maybe there are still galaxies being created? Like that's obviously could be a possibility.
Oh, we know there's still galaxies being created and they merge.
I knew there's some are heading like Andromeda is always like heading towards us, isn't it?
Maybe heading towards us. I think that they keep redoing the math on that one.
Yeah. Okay.
Yeah.
So yeah, you were saying sorry about that.
Yeah. So I mean, so the Fermi paradox just tries to make it.
What's heading towards us?
Oh, the Andromeda Galaxy. They think it may
that
be
was a
potential.
science fiction show, Andromeda. I never watched it, but I heard about it.
Yeah,
so
Andromeda
here's
is
the thing.
nearest. It's the nearest galaxy to us.
nearest galaxy.
But here's the
to
thing
us.
about galaxies, right? And
Now, hold
space
up.
in general.
So is it coming to swallow us, or what's this story? Is this horrifying?
If the math is right, and math is they're always changing it. But anyway, and I say that the astrophysics people like Dr. Rob on 95.7, right?
Okay.
He's doing this kind of math, computational astrophysics, where they're looking at the path of galaxies and where they're going.
Yeah.
Okay. So in like 2 billion years, there's a simulation that shows that galaxy will merge with our galaxy.
Okay.
Because stars do that sometimes, then black holes do that, and things like that. Yeah.
But here's the thing: space is
we'll be gone.
Space is very empty. So let's say 2 billion years ago, we've got our galaxy, 300 billion stars, Andromeda galaxy, 300 billion stars. Space is so empty that there's a really low chance that even 2 stars will even hit each other.
Yeah.
They'll pass through each other. They'll pass back through each other. And they'll do this dance for a while. And then in the future form some sort of mega galaxy out of the 2. So I think, even if we were here, we'd be fine. The other crazy thing. So the Andromeda galaxy, you can see it in the night sky. Like if you were to go out tonight.
You can go and look at it.
Tonight. And you're in,
let's say 200 million light years away.
So let's say you go out to Peggy's Cove, somewhere where it's dark, and you look at the Andromeda galaxy. You see it there, and it's it's kind of dim, but you can see it. It looks like a little smudge near the constellation Cassiopeia, the constellation that looks like a big W.
Okay.
All right. So fast forward 2 billion years in the future, Andromeda galaxy's on top of us. How bright it's going to be? How bright is it going to be?
I would think it would be extremely bright, but I don't know.
No.
Really?
It does. Things don't get brighter. It's a common misconception in astronomy. So a star, if it's a point source, it'll get brighter as it gets closer, right? But if you take an object like a book,
right?
So I hold the book way over here. It's this bright. If I put it here,
well, I guess the light. Yeah, it's not because the light reflecting off it is not changing.
Yeah. Well. So you're getting more light, but it's spread over a larger area. So it's the same proportion. So I think it's a common misconception that is like if a nebula, you see this cool nebula. Oh, if we were that much closer, it would look that much better. It's like, well, not really.
But if the sun got real close to us, wouldn't it?
That'd be bad.
Yeah.
That would be bad for different reasons. And it will.
Got about 8 minutes to live.
And it will someday. But that's a different discussion.
Yeah, it's going to explode at some point.
No, not explode. It would turn into a red. The life cycle of the sun turns into a red giant.
I start to hate this part of the space discussion, right? I like the happy parts of space
discussion. This is the almost done our beer space discussion.
So going back, so the Fermi paradox basically kind of says the likelihood that, and I think there is a likelihood that there's life somewhere else. I think that is the likelihood of it. But the Fermi paradox kind of goes into if it was intelligent life with this many people looking for it, if there was intelligent life that's beyond us, like that is more advanced than us, then we would have found it by now. And the fact that we haven't means that there's none. Nothing more advanced than us.
Didn't we find stuff on like a cellular level though? Like
But but that's
like-
not. But we're talking about advanced beyond us.
Okay.
So what I like about this is like there's people out there who are like, yeah, we're being invaded by aliens and all this other stuff. But the fact is that it's just as probable that there is some other advanced life form that is way beyond us, as it is just as probable that we are number one. People don't think that. People just think that.
So
just
there's a science fiction book called Hyperion that tackles that, and what happens in the setting of the book, not the plot, is that intelligences form in the galaxy or in the universe, and then so you have, let's say AI takes over the world and then gets super smart, but then what happens, and this is just the setting again, not the plot, is they realize that there's other intelligences out there that are formed that might be a threat to it, and they hide.
Oh.
It's also, it might only be a brief moment in time in a species history where they're transmitting data out into the universe. So like right now, we transmit a lot of radio waves out into space, our television stations and whatnot, but that might end for any number of reasons. And so that might just be a blip in civilization's history where they're actually transmitting something that another civilization could perceive.
But like sound will continue to travel and everything. So like we could potentially get something from at some point could get some sort of radio waves from an existence of something that existed like 1 million years ago or something like that.
Another thing that's I think is interesting is that, we get a lot of repeating signals in space.
Yeah. Isn't there like a signal that we don't know or can't identify that we're constantly getting?
Sure. But it's what's interesting to me about that is the first thought of the general public is it's aliens.
Yes.
The first thought of an astronomer is that everything in nature is repeating, like planets rotate. Right. And, a lot of these signals are what's called pulsars. And so you basically just have a star that rotates really fast, but its axis, its magnetic field axis is tilted. And you have radio waves that come out of the top of the magnetic axis. And so it's only occasionally during its spin that those radio waves hit Earth. And so you get a blinking, you get a pattern.
Interesting.
And so there's a lot of things in space that have repeating patterns, but it's just a function of that things go around other things or things are spinning. And so that's what creates these repeating patterns. It's not that there's an intelligence out, like it would be a random pattern would be a much higher probability of it being intelligent than a repeating pattern. If that makes any sense.
Yeah. Okay. Yeah. So what do you think? Do you think that we've been visited?
Do I think we've been visited?
Yeah.
So space is huge.
Yeah.
It's hugely big. And the speed of light is, in astronomical terms, is insanely slow. Speed of light is very slow. To get through between the stars, it takes a long time. Yeah. Even the closest, remember there's 300 billion stars in the galaxy. Yeah. The closest star is like, if the fastest human-made object would still take like 80,000 years to get to it.
Right.
Space is big. And so have we been visited? That's, super unlikely.
I subscribe to that as well, personally. I think the likelihood, because you said 80,000 years, and that's if you can go with the speed of like maybe even the speed of light, or even just slightly less than the speed of light. Right. A lot of people think, like, again, Star Trek. It's like, oh, we'll just go warp 2 or whatever. Right?
But going back to philosophy, though, there's probably an equal probability that we've been visited by aliens as we've been visited by interdimensional beings. So they're not coming from space, they're coming from time, or they're coming from some other dimension that we haven't thought of. So
that's quantum. So that's getting into quantum, though, right?
Well, they're all equally unlikely, right?
Yeah.
Likely or unlikely. So yeah.
Which is interesting, because then there's the whole idea that we're all on a fabric, right? Like their existence is in a fabric, and the idea is that warp can, because we can't go. Solid carbon can't go the speed of light because we get stretched out and we just get ripped apart. But when people think about warp, is they think we're just going to go really fast, but people sometimes think that the theory behind it is that the fabric of space actually gets bent and you just poke through, like, for the whole of it.
There's a lot to unpack there.
There's a lot to unpack there. I know.
Yeah, no,
I spent a lot of time.
So I think that's an amazing concept, being able to bend space, to sort of break that rule, so you're not going faster than light.
Right.
Because that doesn't make any sense. You're bending space.
Right.
My current understanding was it would take, you could do it, but it would take like all the energy in the universe to do it. So,
okay.
Yeah. Maybe we'll find a way around that. I don't know. I'm actually optimistic on that.
Yeah.
Because, we don't know what we don't know, but
that's true.
The laws of physics as we know it say not possible.
Right.
But, they said we couldn't fly. So,
Yeah. I mean, but as you said earlier, like the amount of energy in order to just leave the Earth is insane. Like they fill, when you look at a spaceship, it's 90% fuel.
Yeah.
Right?
So you typically with a spacecraft have about 3% mass to orbit. So that of the whole rocket ship, only 3% is what you would call payload.
Yeah.
Yeah. And that's what goes to space.
Yeah.
But that's speaking of the Pluto mission. Really, really cool. So you have this giant rocket. I forget what kind of rocket it was. And it has this huge fairing on top. The fairing is what protects the spacecraft. And after the spacecraft is in space, the fairing falls off, and then the spacecraft, goes on its way. That spacecraft was the size of a grand piano, right? That rocket was the size of the tallest building in Halifax.
Right. Exactly.
The fairing, which is the case that protects the spacecraft, is like about twice the size of a school bus.
Okay.
Right.
Yeah.
And so it's a really interesting design in which you have this giant rocket with this giant fairing with all this empty space in it. The reason for the empty space is just because their fairings are standardized sizes to effectively buy them off the shelf. But, you have all this mass and fuel and everything just to get this grand piano up to 70,000 miles per hour or kilometers per hour. Sorry.
And so that's something I actually heard Neil deGrasse Tyson talk about. And because somebody asked him if rocket ships are ever going to be able to go electric. Well, no, sorry, it wasn't Neil. Sorry, it was actually Elon. They actually asked Elon Musk. They're like, is Tesla looking into doing that? And he basically said, won't be able to happen. He said, there's not enough power that electric can do it. Like it needs to be that so
there is a company called Spin Launch, and if you don't care about the G load, you can send stuff into space hypothetically very cheaply if it can pull like 100 to 200 Gs. So a human and a space launch only does 3 or 4 Gs, so 3 or 4 times your weight in gravity is what's pushing down on you. With Spin Launch, you have this big sort of disc-shaped object with an arm inside that spins your spacecraft up really, really fast because it has to go 27,000 miles an hour, kilometers an hour. Sorry,
a person couldn't ride in that.
No, a person would get squished. So to orbit, you can go to space and fall back down like Jeff Bezos's New Shepard rocket, but if you want to stay in space, you got to hit that minimum velocity of 27,000 kilometers per hour. And so hypothetically, you could use Spin Launch, which is a centrifuge, and it spins up the rocket in the cylinder, and then it lets it go, and then it's going at orbital velocity. And so it would go through the atmosphere. You probably have a boost or a kick stage to get it up to the final velocity, but that is mainly electric. So that might be a less expensive way. Cause right now to buy a rocket, it is like, a Falcon 9 is maybe $90 million off the top of my head. Yeah. It's not cheap.
No, but we as like what Tobin just said, like we wouldn't be able to send people that way. It would just be satellites and things of the such, right? Yeah.
So fortunately, costs are coming way down now with reusable rockets. So Rocket Lab, was this morning or last night, is the latest company to reuse to recover a first stage booster. Because typically you just drop them in the ocean.
Right. Yeah.
For the last 60 years, you've just been, maybe even 70 now, whatever that is, since 1957, we've just been dropping those first stage boosters and they've been destroyed. That's why it was interesting when there was such a hubbub about the Starship booster, falling into the ocean and making debris. I mean, it's a huge booster, but that's what everyone's been doing since the dawn of the space age, is just destroying their first stage boosters. So,
you just got my wheels spinning here. I'm still wrapped up in this sending things into space and stuff like that. I'm just thinking maybe that's how we can clean up the planet. Let's just launch things into space.
3 tons at a time.
Just launch
a few bags of garbage,
bunch of bags into the sun.
Do you guys know about the Parker Solar Probe?
No, I don't
So
know.
Parker Solar Probe is a solar observatory. It was built at Johns Hopkins, again, where I go to school. And so it took 9 years, and I think it's super close to the sun. So it's the closest object that humanity has ever sent to the sun. It's also the fastest we've ever gotten an object going. It's going at 700,000 kilometers per hour. So about 0.1 light speed, which is insanely fast. But the amount of energy it takes to even get within 30 million kilometers of the sun, which is really darn close. I believe that's within the sun's corona. The sun's about a million miles in diameter. So you're still about, 30 suns away from the sun. Right. But still, like to get that close, and it didn't just take the launch energy from Earth. What you do is you launch it, you go around the sun, you go to Venus, you borrow some energy from Venus, so Venus gets slower, your spacecraft gets faster. You go to Earth, Earth gets slower, the spacecraft gets faster. You go back around the sun, you go to Venus, Venus gets slower, spacecraft gets faster. And then you go around Venus like 7 more times. Wow. And now you've got enough energy to get that close to the sun.
Holy smokes.
All right. Or losing it. It's the same thing. Gaining energy, losing energy takes a lot of fuel and energy to get that close to the sun. So shooting garbage into this, like if you were actually to put it in the sun, I'm guessing it would be almost $1 billion a pound. Really rough estimate.
Great idea for a science fiction movie, though. It's like aliens just throwing the garbage at us, and
but
we have
realistically,
to respond.
we could just send it off into space. I mean, there's a whole lot of room up there.
Well, so space debris is one of the biggest issues that
with satellites
the world is dealing with right now.
Well, satellites are but the satellites are still within our orbit. They're actually all satellites.
So we're going to the space garbage bit.
Yeah, space garbage, big problem. So because everything up there that's in orbit, if it's in low Earth orbit, it's traveling 27,000 miles per hour. Even a paint scratch or a paint chip could destroy your space vehicle. Mm-hmm. And so basically anything around the size of a deck of cards and larger is tracked. There's a division of the United States Space Force, and they've got in Vandenberg, California. It's actually two squadrons, I believe. And what they do is they have radar stations all over the world, and they track this space junk. And if you're a satellite operator and they can tell about 9 days out whether there's going to be a convergence of a piece of space junk and your spacecraft, they will call you and text you. Like they have your number, and they will say, "Hey, there's a convergence that's happening that may happen in 9 days," and they give you. They call you if there's less than a 1 in 10,000 chance, and they're like, "Be aware." And then 5 days before the conversion, they might call you again and be like, "Oh, it's still 1 in 10,000. You should move your spacecraft."
Right.
And this happens all the time.
Yeah, the Convergence movie was built around that, wasn't it, with George Clooney?
The movie? I don't know.
Did you see it?
No. Yeah, but there've been several cases. There's been a case of 2 satellites colliding. Mm-hmm. I think it was an Iridium and some Russian satellite. They collided, and that creates a huge cloud of space debris. And then that cloud of space debris, you need to track that, and then that has been responsible for, a lot of these other. If it's the space station, you call it a DAM, damage avoidance maneuver, and so you have to fire a thruster on the space station to change the orbit to reduce the probability of impact below whatever their threshold is. Yeah.
Aren't all satellites essentially just falling to Earth, though?
So an orbit in general is just you're falling towards the planet and missing.
And missing constantly. Yeah. So it's basically, the space station is just falling. Yeah.
But most of the orbits for low Earth orbit, they're pretty much circular. Yeah. You can have elliptical orbits, like they're called Molniya. I can't even say it. So the Russians can't use geostationary satellites that are over the equator because there's too much of an angle if they're trying to communicate up north. And so they use these satellites that orbit and they go over the same spot every 12 hours or so. And so they sort of sweep up, they hang up above Russia but at higher latitudes, and then they sweep down around the other side of the Earth, come back up, and they hang. Because when you're at the highest point of your orbit, you're moving the slowest.
Right.
And then so you have a constellation of these satellites, and you can have constant coverage over your area. You can also use it to spy on people too. So popular spy satellite.
This is something that we could talk. I told Mike that I was like, "Oh, this is going to go 2 hours," kind of thing. Because
he said 3.
I could talk until the morning, right?
Yeah.
Especially about a lot of this stuff, because especially when you get into some of the more philosophical sciences and things like that, because I find it absolutely fascinating, like, just multiverses, whatever, right? And some of the more, I guess quantum stuff and whatever, right? But aliens is, I think, is the biggest thing, is what everyone. But I don't know. I'm just gonna say I think I'm team we're number one.
Sorry, what?
I'm team we're number one. I think it's it. We're number one, at least in the galaxy.
You think we're the smartest thing out there?
I think we're the most advanced.
Yeah.
I'm not a scientist.
So if you were to assign a probability to that, what's your probability that we're number one?
Oh,
Yeah. Is it
not that smart, but
is it 90% probability? I give that about a 10%.
really, 10%.
It's pretty low.
So you
I don't think we'll.
you think there's a 90% chance that there's a greater advanced life than us in this galaxy? We'll just say.
Yeah, but remember that could be. We don't know if that's like hyper intelligent whales or some
exactly.
like
It
advanced.
could be
You
rocks,
just don't know.
right?
It could be whatever, right?
Yeah.
One thing that's interesting about space to me, and I know we got to wrap it up, but like as we go forward, there's going to be less and less astronauts who are like test pilots and with military backgrounds, and more artists and people using space to sort of expand their horizons in not in outside of STEM,
Right.
and so you'll have more poets and painters and VR artists and movie makers going to space, especially as the costs come down, because they're going down faster than, it could be an exponential cost decline with what's happening in the industry right now.
Afternoon pint in space.
In space. There you go.
AP in space.
AP in space. There you go. That's really taking it on the road.
Could happen.
Yeah.
Yeah, exactly.
Awesome. Well, on that, guys, I think we should cheers.
Yeah, you know what? Thank you very much. This could have gone on a lot longer, but cheers.
Cheers.